Hello everyone and welcome. My name is Zoran. I am Cloud Solutions Architect, and in this video I'm presenting a project called Enterprise AI Orchestration Platform. In the previous 4 videos in this series, I demonstrated individual AI capabilities in a real environment: HyperReg, Text-to-SQL, Multimodal document processing, and MCP. So, in this video, I will not go deep into each of those capabilities individually. If you want to understand them in detail, I recommend watching the previous videos in this series. In this project, the idea is different. Instead of treating each AI capability as a separate solution, the goal is to bring them together under one shared enterprise orchestration layer. Why? Because in a real AI transformation, companies often start by solving retrieval, structured analytics, document intelligence, and enterprise action scenarios separately. That may work at the beginning, but in a larger enterprise environment, the real challenge becomes control. Who decides which capability should be used? How is evidence validated? How is traceability preserved? And how are AI-triggered actions governed? This project is not just about connecting services. It is about controlled decision-making. When, how, and why each AI capability should be used. Another important idea is that the quality of an AI response does not depend on one capability alone. In real enterprise scenarios, reliable answers often come from combining multiple sources of truth: structured data, enterprise documents, operational evidence, multimodal information, and governance context. That is why the right answer is not just one isolated AI call. The right answer is a composition of validated sources controlled through one orchestration process. The "my" in idea is simple: one central orchestrator, multiple specialized AI capabilities, shared governance, shared traceability, and a shared identity model. I will also demonstrate a very important enterprise AI principle. The AI model should not guess. If the platform does not have enough context or validated data, the AI model does not invent an answer. The orchestrator stops execution and asks for clarification. This project is implemented as a realistic Azure-based reference platform, but the architectural principles can also apply to other cloud platforms such as AWS or Google Cloud. Next, I will briefly show the infrastructure, explain system in the combined logical and physical architecture diagram, and then move into the UI with real user questions and responses. If you would like to explore the project in more detail, the complete source code, architecture documentation, and full project documentation are available on my GitHub repository at address above. The repository includes the platform architecture, orchestration design, capability services, governance workflows, deployment structure, and supporting documentation used throughout this project. Before we move into the orchestration scenarios, I want to briefly show the infrastructure this system runs on. The platform is implemented as an Azure-based enterprise environment with multiple independent services working together as part of the orchestration process. Here we can see the central Azure resource group with the AI, data, messaging, and application services required for the platform. I will not spend too much time on every Azure resource because the goal of this video is not an Azure deployment walkthrough. The goal is to show a real enterprise AI orchestration platform running on real cloud infrastructure. When we move into the container apps environment, we can see the backend services that make up the platform. The central service is Orchestrator API. It coordinates all capability services and controls the execution flow. The web UI is the user interface, where the user asks business questions and sees answers, evidence, traceability, and execution status. The platform also includes services for retrieval: Text-to-SQL, multimodal document, Q&A, artifact handling, MCP gateway, approval workflows, tool execution, and MCP results. So instead of one large monolithic AI service, the platform is built from multiple focused back-end services with clear responsibilities. It is important to note that neither the user nor the AI model communicates directly with individual capability services. All communication goes through the orchestrator. The orchestrator decides which capability should be used, in what order, and how execution should be controlled. In the background, the platform uses Azure Service Bus for queue-based orchestration and asynchronous communication. Azure SQL and Blob storage are used as main data sources in this project, while Azure AI Search and Azure OpenAI support retrieval, planning, embeddings, summarization, and answer synthesis. The goal of this infrastructure is not just to connect AI services. The goal is to create a controlled enterprise orchestration model where multiple AI capabilities can work together to produce reliable, traceable business answers. Before we move into the UI demonstration, I want to explain how the platform works through one combined diagram that connects the logical and physical architecture. This diagram shows how a user's business question moves through real enterprise AI infrastructure from the UI through the orchestrator to capability services, evidence sources, governance, and the final answer. At the highest level, everything starts in the user interface. The user asks a business question in natural language. This could be a CIO, COO, risk manager, or operations lead who needs a reliable answer without dealing with technical details. The question then goes to Orchestrator API. It is important to understand that the orchestrator is not just a proxy, and it is also not an AI model that guesses what should happen. The orchestrator needs clear information to continue. What the user is asking for, which capability should be used, what data is needed, whether the entity is clear, and whether governance or approval is required. That is why the orchestrator sends the request to the planner model. The planner model analyzes the question and returns a structured execution decision. Depending on the question, the planner may select only one capability, such as Text-to-SQL, or it may combine multiple capabilities, such as Text-to-SQL, Hyper, RAG, Multimodal, and MCP. The orchestrator does not accept the plan blindly. It validates the planning result, checks whether the selected capabilities are known, verifies whether the entity context is clear, and decides whether execution can safely continue. If the context is not clear enough, the platform stops and asks the user for clarification. This is one of the most important enterprise AI principles in the project. The AI model should not guess, and the orchestrator should not execute without reliable context. When the plan is valid, the orchestrator prepares the execution context. That includes conversation context, resolved entity, selected capability chain, evidence scope, trace identifiers, and metadata for the execution lifecycle. Then the orchestrator calls the appropriate backend capability services according to the planner model's decision. If the request includes an enterprise action, such as sending an executive summary, adding a case note, or triggering an escalation workflow, the orchestrator uses MCP Gateway API. AI actions do not go directly to enterprise systems. They pass through the MCP Gateway, queue-based dispatch, approval when required, execution service, and result tracking. That is why the architecture also includes Approval API, Tool Execution API, and MCP Result API. In the physical architecture, these services run as separate backend services in Azure Container Apps. This keeps service responsibilities clear and allows each part of the platform to be configured, scaled, and controlled independently. On the data side, this project uses Azure SQL and Blob storage as main data sources, but the same architecture could connect to CRM, ERP, data warehouse, ticketing systems, SharePoint, ServiceNow, Salesforce, or internal operational systems. Azure AI Search supports retrieval and multimodal document evidence. Azure OpenAI supports planner reasoning, embeddings, summarization, and answer synthesis. Azure Service Bus supports asynchronous communication and queue-based execution, especially for MCP and approval workflows. One of the most important points is that neither the user nor the AI model communicates directly with capability services or enterprise systems. Everything goes through the orchestrator and governance layer. At the end of the execution process, the orchestrator first prepares the grounded context package and sends validated data to the answer synthesis model. This package can contains results returned from capabilities, governance instructions, and traceability references. Only after that is the final answer generated. So, the answer the user receives is not just ordinary AI text. It is the result of a controlled orchestration process, where capabilities are selected, evidence is collected, context is prepared, governance is applied, and traceability is preserved. Now that we have a clear picture of how the platform works internally, we can move into the UI and see this orchestration model in real business scenarios. At this stage, we are no longer talking about architecture in theory. We are going to see how the platform behaves when a real user asks a real business question. During this demonstration, pay attention to several important things. How the orchestrator understands the request, how the planner selects capabilities, how evidence is collected, how traceability is preserved, and how AI moves from analysis into controlled enterprise execution. Before I start asking questions in the UI and reviewing the platform responses, let's briefly define the business scenario used in this demo. In this scenario, Zoran Enterprise Group is a large enterprise organization that manages multiple business units across different industries. The business units are Zoran Advanced Manufacturing, Zoran Health Systems, and Texas Logistics Group. All questions in this demo will be based on this business scenario. The goal is to show how the platform can analyze operational risk, business impact, supporting evidence, executive escalation needs, and governed enterprise actions across multiple business units under one enterprise group. In the first example, the user asks, which business unit currently represents the highest operational risk to the enterprise based on the latest operational metrics, projected business impact, escalation activity, resilience indicators, and forecast risk trend? This is a very typical enterprise operational risk question that would most likely come from a business leaders or executive operations leader. And immediately we can notice something very important. The user does not choose a service, does not write SQL queries, and does not know where the data is located. The user simply asks a business question in natural language. And that is exactly where the orchestrator begins its work. Inside the planner decision section, we can see that the planner model analyzes the request and determines that text-to-SQL is sufficient for this scenario. This means the orchestrator did not activate unnecessary services or trigger a more complex execution flow than required. This is a very important enterprise principle: controlled orchestration and optimized execution. In the capability pipeline section, we can see that only the text-to-SQL workflow was executed. The platform then generates a read-only SQL analysis against operational data and returns the result. Inside the final answer section, we now see something very important. The AI response is not generic text. The answer is grounded in real operational metrics, risk score, projected impact, incident count, escalation activity, and resilience indicators. But perhaps the most important part appears below in the evidence and grounding section. Here, the platform transparently exposes the SQL evidence and even the exact query that was used. This means the response is not trust the AI model. The response is verifiable, traceable, and grounded in real enterprise data. Then through the grounded context package, the orchestrator prepares validated information before the answer synthesis model generates the final business response. And this is really the core idea behind the entire project. The user asks a natural business question, The orchestrator selects the capability, evidence is validated, and the AI model generates a response based on controlled context. In the next example, the user asks a very short follow-up question. Why? This may look simply, but architecturally, it is very significant. The platform now has to understand conversation context. Inside the conversation context section, we can see that the orchestrator uses the previous analysis and understands that the user is really asking, why was this particular business unit identified as the highest operational risk? This is the first time we see true multi-capability orchestration. The planner now selects Text-to-SQL and HyperRAG. First, structured operational data is used to identify the business unit and its metrics. Then the orchestrator automatically activates the HyperRAG capability in order to retrieve narrative business context and additional enterprise evidence. And this is one of the most important moments. The platform combines specialized capabilities through a controlled orchestration flow. Inside the evidence section, we can now clearly see two different types of evidence: SQL evidence with structured operational data, and HyperRAG evidence containing retrieved enterprise documentation context. At this point, the answer is no longer just a numerical result. The AI provides a real business explanation: visibility issues, slow incident response, manual operational processes, operational instability, and escalation concerns. In other words, the platform combines structured data, retrieval evidence, and AI synthesis into a single grounded executive response. In the next example, the user submits a very simple request: send me this on email. And here the platform transitions from AI reasoning into governed enterprise execution. The planner no longer selects Text-to-SQL or HyperRAG. Instead, it selects the MCP capability, because the user is no longer asking for analysis. The user is asking for action. Inside the MCP action status section, we can now see several important enterprise execution details: which tool was selected, the request AID, queue status, dispatch channel, and the target system. This is extremely important because it demonstrates that AI actions are not uncontrolled. The action moves through a controlled MCP orchestration flow and Azure Service Bus dispatch infrastructure. This provides traceability, auditability, and controlled enterprise execution. We can then see the generated executive email result. And this is very important to understand. This is not a static email template. The platform dynamically generates the executive summary using SQL evidence, HyperRAG evidence, orchestration context, and governance metadata. The email even includes capability chain information, evidence references, and trace identifiers. This means the platform maintains governance and traceability even when AI executes enterprise actions. In the next example, the user asks, explain the operational and governance concerns contributing to the current executive risk posture of the highest risk business unit and summarize the recommended leadership response. At this stage, the platform is no longer performing only operational analysis. Now the request involves executive reasoning, governance assessment, and leadership recommendations. This is where the platform evolves beyond an analytics tool. It becomes an enterprise executive decision support platform. The planner once again combines Text-to-SQL and HyperRAG capabilities. Structured operational metrics are combined with narrative enterprise evidence so the AI can generate a true executive risk narrative. The response now includes operational instability, production downtime, governance weaknesses, open escalations, and executive accountability concerns. But the platform goes even further. It does not only describe the problem, it also recommends leadership actions and executive prioritization. And this is a major difference between a standard AI chatbot and an enterprise orchestration platform. In the next example, the user asks, identify the business unit requiring immediate executive attention generate an executive operational risk summary using the latest operational metrics and supporting evidence, and notify the executive operations leadership team with the recommended escalation context. This is the first time we see the full orchestration chain: Text-to-SQL, Hyper-RAG, and MCP together. This is essentially the entire platform operating within a single workflow. First, the platform analyzes operational metrics. Then Hyper-RAG retrieves narrative enterprise evidence. After that, MCP initiates a governed executive notification workflow. And now we can clearly see the true value of the orchestration model. AI is not only generating answers, AE can understand the business problem, retrieve evidence, generate conclusions, and trigger controlled enterprise actions. We then see the final executive email result. The platform automatically generates an operational summary for the leadership team using the complete orchestration context. This clearly demonstrates that the system can transform AI analysis into a real enterprise workflow. In the next example, the user asks, review current operational risk for Zoran Advanced Manufacturing using structured risk metrics and the latest inspection reports, then explain whether any facility safety risks increase the need for executive escalation. Here the platform demonstrates one of its most advanced capability areas: multimodal reasoning. The planner selects Text-to-SQL and the multimodal capability. The platform is no longer understanding only tables and metrics. It is now understanding operational context from real inspection documents. On the right side, we can see multimodal evidence where the system identifies a warehouse safety issue and connects it to executive escalation risk. This is a very powerful enterprise scenario because it demonstrates that AI can combine operational analytics, document intelligence, and multimodal reasoning within a single orchestration workflow. In the next example, the user asks, review the operational health of Zoran Enterprise Group business units and identify which division presents the highest near-term business risk, including the factors contributing to that assessment. And here the platform demonstrates a massive difference between an enterprise AI orchestration platform and a standard AI agent. And now try to extend question, adding add a case note. The AI is now attempting to execute a write action against an enterprise system. But the action is not executed automatically. Inside the final answer section, we can see awaiting approval. The planner selects the MCP capability and flags the execution as requiring a governance approval workflow. When we open the approval screen, we can see who initiated the action, what the AI intends to do, which system is being targeted, the conversation ID, the grounding trace ID, and the content of the action itself. In other words, the human remains in control. The AI may recommend an action, but it cannot independently execute a high-risk write operation. Only after approval does the workflow move into completed status. This is one of the most important enterprise aspects of the entire project: AI governance with human oversight. In the next example, the user asks, for Zoran Enterprise Group, if the current operational trend continues through the next 2 quarters, what is the projected business impact across the portfolio? And which executive actions should be prioritized first? Here the platform moves from operational analytics into strategic forecasting and executive planning. The system is now evaluating future business impact, renewal risk, revenue exposure, and executive prioritization. The AI is no longer analyzing only the current state. It is now attempting to estimate what may happen if operational trends continue over future quarters. The platform then recommends prioritize executive actions: executive risk review, reliability escalation, and mitigation planning. In the next example, the user asks, compare operational resilience across all Zoran Enterprise Group business units and identify which division is most likely to require executive intervention next quarter. Here the platform demonstrates portfolio-wide operational comparison and executive prioritization. It is important to notice that the orchestrator selects only the text-to-SQL capability for this scenario. The planner determines that structured operational data alone is sufficient for this comparative ranking analysis. And this demonstrates another important enterprise principle. The platform does not activate more complex capabilities when they are not necessary. This helps control latency, execution complexity, and operational cost. It is also important that the platform clearly exposes evidence limitations and does not hallucinate when complete comparative resilience data is not available across all business units. In the next example, the user asks, compare 3 response strategies for Zoran Advanced Manufacturing. No intervention for 60 days, immediate executive escalation, and SLA recovery plan within 14 days. Show projected risk, financial impact, operational impact, and recommended action. Then send result to leadership team by email. Here we are essentially seeing the complete enterprise AI orchestration platform operating at full capacity. The platform now combines predictive operational analysis, mitigation comparison, executive reasoning, governance, and controlled enterprise execution. The planner selects the complete orchestration chain: Text-to-SQL, HyperRAG, and MCP. The platform evaluates operational and financial impact for each strategy, recommends the best mitigation plan, and then automatically generates an executive leadership email. This is an extremely important scenario because it demonstrates that the system can analyze a business problem, estimate future impact, recommend actions, and trigger enterprise workflows within a single controlled orchestration process. And finally, the last scenario demonstrates perhaps the single most important enterprise AI capability in the entire platform. The user asks, review the operational risk situation and identify which division requires immediate executive intervention. Also prepare an executive escalation summary and notify leadership if the risk is critical. And here, the platform demonstrates something extremely important. The AI model does not guess. The system does not invent answers. It does not assume the target entity. It does not trigger enterprise actions without validated context. Instead, execution stops, the planner returns a needs clarification status, and the platform requests additional information from the user. The platform even proposes several possible business unit options: Zoran Advanced Manufacturing, Texas Logistics Group, or Zoran Health Systems. A typical AI model would most likely attempt to guess the answer. This platform does the opposite. It validates context first, checks entity scope, and only then allows execution to continue. And that really brings the entire project story together. The goal was never to build an AI that always says something. The goal was to build an enterprise AI orchestration platform that understands business problems, selects the appropriate capabilities, controls execution, maintains governance and traceability, and generates responses only when sufficient validated evidence context exists. And that brings us to the end of this enterprise AI orchestration platform demonstration. In this video, we saw that the real value of enterprise AI is not in a single model or a single capability. The real value comes from orchestration, combining structured data, documents, multimodal evidence, governance, traceability, and controlled enterprise actions into one unified workflow. We also saw that the platform is mature enough to deliver accurate evidence-based answers, but also to support predictive analysis and executive forecasting, which are now expected from modern AI systems. Another important enterprise principle is that the AI model does not guess. If the context is not clear, the platform stops and asks for clarification. I did not go deep into security, compliance, and identity in this video, but those are critical parts of the architecture, and I will cover them in the next video. Thank you for watching, and I hope this project gave you a clear view of how enterprise AI orchestration can work in a real cloud environment.